All right. Good afternoon and happy Thursday. It's October 26th, and I'm planning on doing the LeetCode Daily Challenge for the day. So, share my screen. Let's start jamming here. Okay, 26. Generate trees with factors. Strictly greater than one. Okay, so we should be able to use the rule of product, right? So, sort A. Here's a, keep track of what time it is, 2:29 p.m. Game plan. Oops. Game plan is to sort A. Then formulate the count on since the factors of 10 are 2 and 5, this is process those. And for 10, it's the amount of twos, the amount of fives. Both ways, I guess. So two different values. Before we can reuse the same two twice, but only once. Okay, so for each parent node, the count is the amount to the left multiplied by the amount to the right, and then multiply it by 2 if they're not the same. The parent is right, look at child count multiplied by the right child count multiplied by 2 if left and right child values differ. Okay, right? I think so. So process the 2, that one's just 1. And then process the 4, 1 itself, and plus 1 for each parent node. The parent node could be a leaf node too, just 2 by itself, 4 by itself. So we can just accumulate n and return that. N would be the Cardinalian for A plus 6 even that we accumulate in piecemeal fashion. It's for sorted A, 4xn sorted A. So we can just have maybe a map for each value x. Each value x. Count might just be a counter. Here's A plus counter sum, right? Sum of count values modulus hello. Hey, I was doing a LeetCode for the day. Hello. Yeah, I was just doing some LeetCoding here. Okay, sure. Okay, yeah, that sounds good. Can you get me some peaches? Ooh, okay, yeah, that sounds good. Yeah, I'll go pick up Denny here in a little bit. Okay, and then I'll just go to that same door and knock, right? Okay, yeah, I'll set an alarm to go, and then I'll get there a little ahead of time. Alrighty, yeah, love you. Bye. Okay, let's see. I give myself like 10 more minutes. And I could go in here. All right, so yeah, anyhow, give myself 10 more minutes and we'll get out of here at 2:45. All right, so for each value X in there, then count of X is one, right? And then right, so let's see, we're going to count this. Oh, so, oh, unless if if we haven't seen it, we've already run into, let's see, unique integers. Okay, that should be fine. So for y and range two to the square root of x plus one, or square root of x inclusive. If so, for x is not equal to y and x like this y is equal to 0. C equals x evenly divisible by y. Right, so y times z would equal x. Y not equal to z. And we'll also have 2 equals 1, which we can multiply it. Differ. And x well, minus um, 1 multiplied by the count of z. So it's like the left and right child correspondingly. Multiplied by 2 if y does not equal z. Do the law, right? 7. Turning the count. So we'll process 2 first. The count of 2 is 1. For each wide range, 2 to the square root of x. So 2 equals 2. Well, actually, square root of 2 is less than 2, so it doesn't actually get there. Okay, so we process 4, so the count of 4 is 1. Then we do 2 to 2 inclusive. X is 4, y is 2. X is evenly divisible by y. Z would be 2. So the count of 4 will be itself, which is 1, plus the count of, or Z is 2. Yeah, y is 2 and Z is 2. Okay. Count of 2, which is 1, multiplied by the count of 2, which is 1. So that's 1 multiplied by 1 because y is equal to z, right? 2 is 2. Okay, I mean, it seems like it works. Walk through it in like 5 minutes. So if it's not right, we don't have much time to debug. Let's see. It's 2:40 p.m. Oops, 11 minutes. It's taking a while. Okay, that looks okay. It's just updated. And actually, I don't know if we need this. Yeah, we do that. Okay, yeah, we do that. Okay. Holy cow, that took a long time. Okay, I wonder why it took so much longer than my old solution. So it looks like I saw this a year ago. Okay, so let's look at the old solution I came up with. It's interesting. What dynamic programming? Oh, okay, do it recursively. Yeah, interesting. I just do it bottom up, I guess. Yeah, interesting that I use X, Y, and Z for the parent and left and right child correspondingly. So that's kind of cool. And it doesn't really matter, right? You use A, B, C, parent, left, right, X, Y, Z. Right. It's just easier, I think, just to have a single character sometimes in a sequential manner, like A, B, C, X, Y, Z. So again, like the X would be the parent and Y and Z would be left and right child corresponding to that X parent. And that's cool. Like the only reason this actually works here is because Python allows for large values. So this sum would overflow in other languages before you mod it. So there would be another extra step that we'd have to mod. This is pretty cool though, right? So yeah, this is about a year ago. I didn't think of top down, so that's kind of cool. Just straight go to bottom up because bottom up is a little more efficient. Like there's no recursive stack overhead, and there's optimization for memory, right? You don't have to follow the recursive stack of memory sometimes. Okay, well, anyhow, that took 11 minutes for the implementation in Python 3, Python 3, which is assumpted here. And it looks like I beat this thing up pretty good. You know what I have seen here. This is a little bit unnecessary, right? It'd just be 0, right? Like, if it doesn't exist. It Z, it doesn't exist. This is 0. Okay, yeah, I might as well. Here, I can rewrite that. That's silly, right? This is really complex. What do I have the same? What is this? This is kind of junk. Yeah, seeing is not necessary. Yeah, I'll fix that bottom up here real quick, maybe in C++, and then it'd be a good opportunity to demonstrate why we have to accumulate the sum of the map's values in piecemeal fashion, otherwise it wouldn't fail. Using the map. Map. These are all start this thing. Total Okay, so let's do this. T and here. Or let's see, A forward again, and to square root of oops, x inclusive. X is not equal to y, and x modulus y 0. X modulus y. Yeah, I gotta get going here. Okay, so that's cool. Let's create a map real quick. So x. X x plus m sub y multiplied by m sub z. And so I'll create the z here. Z is equal to x divisible by y. So x modulus 7. Plus the count. Okay, something like that. And I'm gonna get going. Oh, 3 and 6. What? Yes. Oh, multiplied by 2 if x is not equal to y. Y by, or yeah, the left child is not equal to the right child. 2 and minus 1. Okay. Pretty sure next flag is missing. Oh, come on. What is this? X is not, y is not equal to z. It's 2 and minus 1. What is this? How many parentheses one that point? Okay, that was good. Okay, right. This is kind of silly. I don't need scene, right? If it's not seen, the count is just 0 using a default value. Okay, anyhow, catch you all later.